Hello again. So I've reached exercise 10, which is to add an element into a hash table based on a coalesced hashing, but without a separated zone. So we don't have this separation, and we need to insert the element into such hash table. So I have here, so I will run the example in order to see what will happen. So we have a hash table of size 10. So I will show you first the hashing value. So if I enter the string A, it will hashes to 7. If I enter B, it will hashes to 8. And if I'll hash C, it will be on 9. So what I will do that is that I will hash the same values at the same place. So let's say that I will hash first the value of A, so it will come to 7. AA also, its hashing value is equal to 7, so it's equal to 9. So look here, we have AA minus 1, and we have changed the link. So whenever we add an element, and if it's occupied by so if they have the same hashing values, I will link them together. For example, now let's say that I will hash the value C. So we know C it's B it hashes to 9, so it should come instead of AA here. So look well. Oh, so B is equal to 8. So let's enter C. So C is equal to 9. So AA, which is at index 9 here, it was relocated to index 6, and even the link of its parent changes also. So we have a lot of to do. So quickly, so if the cell is empty, I just need to add the element, and this is it. Otherwise, for example, like here, if I have added A and then AA, and they both hash the same value. So if I found in index 7 an element that is related to me, that it has the same hashing value than me, then I need to find an empty space in this table, and then link all together. Otherwise, if for example, like in here, I wanted to add C, however there's someone who's not related to me that is taking my place, so I need to kick him out. So I need first to find him a place, an empty slot. So if there's an empty slot, I can move it and then place myself. Otherwise, I cannot do the adding. So let's start. So the hash table size is equal to m, it's equal to 10, and again we have the coalesced hashing. So the entry, so each cell consists of an entry, and then each entry contains the data and the link, and the element is a string of 20 characters, and a hash table is an array of m entry. So the hashing function here is modulo m, it's not modulo p like in the separated zone, because we can use all the array. To create the hash table, I just need to place -2 in the link, and here we will write the function to add an element, and here we have the test and the printing of the table. So let's start. So I have an element E, and m is the size, and we have the hash table. So first we need to check if the hashing of the element E, the placement is empty. So we will need later on R, which will use it in order to find an empty slot. We have I, which is the hashing of the function, the element E here, and we will need a J. So I have the index I need to check if this index is empty or not. So if it's empty, it will be great. I just need to add the element. So to add the element, I need to use strcopy because I'm using a string. So in t of I dot data, and so I will add the element E. For the link, it will be equal to -1 because it's empty. There's no relative for me in this table yet, and then I will return 1. This is the easy part. So if it's not empty, it's either occupied by one of my relatives or it's occupied by someone else. So I need to check. How can I check? I just rehash the string that is in the index I. So I will use a hash function. So I will rehash the element in the index. So it's equal to t of I dot data. So if the hashing function, so if it returns I, so if it means that the element in ti of data is in its correct place, it means that I have some relatives, so I need to find an empty space. So maybe I'm looking for an empty space. It's sometimes that I found myself, so it's repeated element, so I will return 0. So we already done that. So we just loop over t of I dot link. So already done that in the separated zone. So if it's different than -1, and if it's strcmp is not equal, because if it's equal, I will end, so I will not add the element. So I will move, so I would be equal to t of I dot link, and when I am out of the loop, either t of link is equal to -1, it means I have ended the search, so now I can add, or the strcmp is equal to e. If it's equal, it means that the element is already in the table, so there's no need to add it once again. So I return 0. Otherwise, I need to find an empty slot. So again, we already done that. So I will start from the end of the table. So for that, I have started R from m-1, and I will go back. So as long I will start from the end and go back until I reach an empty cell. So as long as it's not empty, I will go back. I will do R minus minus whenever I'm here. So either I have found an empty slot, or I have depleted the array, so all the cells are full. So we can check. So if R is less than 0, it means that there is no cells. I will return 0. Otherwise, it means at index R I have an empty space. So I will copy the new element, which is tr dot data. I will copy the element e. So and then tr dot link, it's the last of the elements, so it's equal to -1, and then I need also to link it to the first element. So it's ti dot link would be equal to r. So why I? Because I'm moving here till the last element. So the last element from those who have the same hashing value, it will be of index I. So the ti of link, it was equal to -1 because I'm here. So I have out of this loop because it's equal to -1. So I just need to link that. And of course, I will do return 1. So I still have one more case, which is my cell. So my original cell is occupied by some other element. So I need to kick this element. So in order to kick this element, I need to find them a place. So I do the same. So I will loop from the end till the beginning. So if I didn't enter in this function, so R would be equal always to m-1. So there is no need to reinitialize the m-1. So I will loop from the end till the start, and if I found an element, I will copy the element. So if R is less than 0, it means that there's no empty cells, there's nothing to do. Otherwise, I need to copy the index. So I have here the empty slot. I need to copy t of I because t of I occupied my cell. Now the cell is empty. I can insert my first element here. So we have a problem here also, because it may that this element I is related to some other elements like we have seen in the example. So I need to rectify its parent link. So the parent of t of I. So for that, I need to find the hashing value. So it means the parent, the ancestor of t of I. So for that, I will be using j. I will calculate the hashing function of t of I dot data. So I will find the root of this guy, and then I will move into the link until I reach di. So as long as t of j dot link is different than I will move with j till I found the parent of I. Then I will modify its link. Now the link would point to it will point to the newest cell, which is equal to R. Now the I index is free, so now I can copy the element t of I dot data e, and the link, since this is the first element, it will be equal to -1, and I will return 1. So let me repeat quickly. So we have the function that we need to write, which is to add an element into a hashing table with coalesced hashing without a separated zone. So first we need to check the hashing of the elements, and then we check the index of this, so the hashing value in this hashing table. If the cell is empty, I just need to add the element, and this is it. Otherwise, there's two cases here. Either I have some relatives, I need to do some job. Otherwise, if there's someone is residing in my place, I need to kick him out, rectify its parent link, and then place myself. So in the case where I have some relatives, I need to find the last element in the hierarchy, and then I need to find, so if the element is in the tree, in the hash table, sorry, it means there's no need to add it, so I return 0. Otherwise, I need to find an empty space, empty cell. So if it's found, this is easy. I just need to add the element, and I have my parent here, the last element, which is at index I just need to link it to the newly found cell, which is at index R. And the other part, whenever there's someone who occupied my place, I need to kick him. In order to kick him, I need to find also an empty slot. So I have found a slot at index R. So I will copy the elements here. So R is the index of the free element that I need to copy T of I into. However, T of I, it may have a parent. So if it have a parent, I need to find it. So I will hash T of I of data and get the index j, and I will loop until the link is equal to I. So in j, I will find the parent of I. Then I will update the link of the parent, which is now will be equal to R, and then the index of I would be empty, and I will do my insertion. So let's rerun and check. So we have here an error. There's no tr of data. It's here tr of link. Run. So enter a string, let's so A, and then I have AA and AAA. So we have all this, and then, for example, I need to insert V. So V, obviously, it should come here, and AA, it will move upper. So we have here a link from A, which is here 9 to 6. Now, if I enter C, so C, it will kick A. So yes. So we have here A, which is linked to 5, and then linked to 6, and is equal to -1. So it's very interesting exercise. So, however, we are not asked here to do the deletion or the searching for an element into such hash table. So it's a very nice exercise if you can do it, and you can send it to me, and if it's correct, I will place it on the website and feature your name. And this is it for this exercise. If you have any questions, do not hesitate to write to me, and of course I will answer you back. And again, thanks for watching.